Welcome to IUFRO Research Group 5.16, Wood Identification. Currently, urgent need for wood identification is driving by enforcing a sustainable forest products strategy. Recent advances have already demonstrated the capacity for improvement on filling the gaps in actual demand for reliable identifications. Here, we will provide you a fresh technique session, advancing wood identification to promote a sustainable supply chain of forest products.
Hello, everyone. Now we will talk about wood collections and databases. Now, a salarium, or wood collection, is a botanical collection that consists of wood samples and derived preparations. In recent times, increasingly supplemented with extensive databases of images and measurements. Some of these salaria are the result of more than a century-lasting collection efforts. And you can see on the slide the different countries listed and the amount of specimens in the salaria. These salaria are of growing importance in the context of ensuring legal trade of timber and certification of sound forest management. This unit aims at strengthening the role of wood collections and research, and we explore how we can exchange materials and facilities so that data mining can be improved. We will establish an international network of researchers involved in the creation of scientific wood collections. The next few slides give an impression of a selection of salaria and the typical ongoing activities. And we start off with the Salarium Bogoriense in Indonesia. This is the Indonesian wood collection, established in 1914. It has been registered in the Index Xylorarium as institutional wood collection in 1957, and in the Index Herbarorium Indonesianum in 2006. The collection consists of botanical authentic samples in the form of trapezoid wood blocks, microslides, and stem discs. You can also see the number of specimens, families, genera, and species on the screen. The Salarium provided the source data for the development of the automatic wood identification system named ICO-KLHK, and this includes 1,392 wood species, and it's gradually being updated with lesser known species. Next up is the wood collections of the Chinese Academy of Forestry. These wood collections have the mission to provide support for scientific research, stimulate international exchange, and involve citizen science. The collection includes 36,000 wood specimens from 9,600 species, 1,900 genera, and 206 families. There are also extended collections of microscopic slides from 1,500 species, 570 genera, and 130 families. These are accompanied by 6,000 herbarium vouchers. Substantial efforts are being paid to digitize the available wood specimens and eventually to generate a digital salarium. The Tervuren wood collection is the Belgian governmental wood collection. Its major focus is on Central Africa, but today its domain is worldwide and contains 80,000 specimens from trees, shrubs, and lianas from 13,000 species. Collection samples include classical book-shaped formats and tin sections, but also contains rich assortments of stem discs and cores, which allows research in the domains of forest ecology, next to comparative anatomy and identification of material from trade, fine arts, archaeology, and paleoecology. Finally, we have the collection at Kew, the collections at Kew. Kew is currently the most actively researched salarium in the United Kingdom. It forms a part of the economic botany collection of around 100,000 items, including artifacts and plant products. Both the salarium and the microscopic slide collection have worldwide coverage with most woody angiosperm and gymnosperm families represented. At Kew, we are constantly improving our wood reference collection, are actively building the World Forest ID collection with georeferenced and accurately botanically named samples suitable for addressing the major issues of deforestation and illegal logging. At Kew, we use these reference collections to apply techniques such as wood anatomy and chemistry to identify wood samples from a wide variety of sources. In the final slide, we'll talk a little bit more about the World Forest ID project, which aims at building the world's largest georeferenced open source forest sample collection to tackle fraud, illegal logging, and deforestation. Now, given the growing interest in wood collections, exchange of ideas about innovative methodologies for better conservation, digitization, extension, and management of wood collections, and associated databases is needed. Salaria will continue to play a key role in wood identification. And to maximally use the power of the state-of-the-art techniques for timber forensic analysis, additional focused collection efforts are useful. That's why the Royal Botanic Gardens Kew the World Resources Institute, AgriWise Lab, the US Forest Service International Programs, and then mainly the Wood Identification and Screening Center, and the Forest Stewardship Council are actively building the World Forest ID collection, which contains georeferenced and accurately botanically named samples, which are being used to address the major issues of deforestation and illegal logging. We use these reference collections to apply techniques such as wood anatomy, dartophorems, xylotron, and stable isoberation analysis to identify the species and origin of timber samples. And for the people interested, you can find more information on the World Forest ID by reading the paper, go to the website, or reading the news article, Cops and Loggers. Thank you very much.
Hello, everybody. Please lend me your ear for a short introduction into the field of Working Group 5.16.02, the anatomical identification of wood. The anatomical identification of wood is based on the structural composition of anatomical features in the wide variation of thousands of timbers. Here's just a tiny representation of the diversity. From each anatomical structure, an individual code can be derived, the anatomical fingerprint, which makes it possible to identify wood species anatomically. Beyond the identification of solid timbers, the special challenge lies in the identification of processed timbers and wooden products, especially in wood-based materials where the individual wood fragments are becoming smaller and smaller, such as plywood and particle boards. For the identification of pulp and paper materials, only a few characteristics, such as the size and the shape of the vessels, as well as the size and the shape of the pits, especially the cross-field pits that you can see here in the presentation, can be used. With these characteristics, wood anatomy is able to differentiate important timbers like acacia, mangifera, or sharea, traded worldwide. A particular challenge also lies in the identification of charcoal and briquettes. As with processed timbers, certain characteristics such as odor, color, and specific white can no longer be assessed. In addition, the production of microtome sections, which can be used in the classic way for the identification of timbers, is no longer possible. Other than for the microscopic determination of solid timbers, charcoal cannot be prepared as flat, planar cut samples, as the woody tissue is strongly decomposed by the charring process and has become very brittle. By using 3D reflected light microscopy, the uneven surfaces are digitally scanned, and then, as a first step, three-dimensional representations are created that are converted into two-dimensional images in a second step, like you can see here with a sample of oak. Another step into the future is coming up with the computational recognition of wood. The wood species classification is an essential field of investigation that can help to combat illegal logging. Then providing the timber certification, allowing the application of correct timber taxing. Today, the wood classification relies on highly qualified professionals that analyze texture patterns on timber sections. However, these professionals are scarce, costly, and subject to failure. Therefore, the automation of this task using computational methods is promising. Deep learning has proven to be the ultimate technique in computer vision tasks, but it has not been much exploited to perform timber classification due to the difficulty of building large databases to train such networks. Additionally, the computational methodology allows fast prediction, which is not affected by human factor. So far, thanks for your attention.
Happy World Day from our division, Multidisciplinary Identification of Wood. Our unit looks at the accuracy and the power of combined research from anatomists, chemists, and geneticists for developing innovative and accurate wood identification suites, with the goal of supporting trade legality and sustainable use of wood resources. These goals often rely on transparent supply chains in commerce. The questions we ask in the supply chain are who, what, and where did a product come from? The who of an individual product to a stump can link individuals to crimes they committed. The what of species identification is critical for supply chain integrity and can be an early factor in identifying leaky supply chains. The Convention on International Trade in Endangered Species, CITES, Conference of the Parties has agreed to include more than 900 tree species under the CITES appendices, and we need tools to identify them. And in a globalized economy where human rights abuses, wildlife poaching, and deforestation are interlinked, our supply chains need to have methods of confirming the origin of the products. The tools we have range from visual methods like imaging tools, chemical and genetic methods, all strengthened by statistical analysis and advances in machine learning. As the methods have matured, many have become tools for answering multiple questions. In tandem with these developments, our knowledge of the complexity of the 60,000 species of trees has shown that not all genera act alike. Anatomical and chemical lookalikes become more frequent, and DNA extraction efficacy from wood products can vary. That has not stopped innovation. For instance, researchers from the Chinese Academy of Forestry have developed a mobile phone app to automate field screening of timbers for CITES implementation and promote citizen science for biodiversity conservation. Similar work with portable and deployable devices has been developed worldwide, including, but not limited to, multiple groups in the United States and Indonesia. The chemical contents of wood can also be studied at different scales. Chemical fingerprinting of a wood sliver based on the complete set of small molecules found within a sample can be done with Dartmouth mass spec. Near-IR infrared spectroscopy looks at the surface of the wood, studying both wood chemicals and physical characteristics of the wood, which can vary both between species and origins. Stable isotope data uses the relative abundance of two stable isotopes of one or several elements for the wood of a specific taxon grown at a specific locality. Genetics has a broad application that can answer different questions depending on how the selection of high-resolution molecular markers is done. For example, this barcode uses nucleotide polymorphisms at the plastid genome level. And with the advent of the big data era, genetic methods will bring more opportunities and tools for wood identification. But none of these techniques works in a silo. Due to the incredible biodiversity of trees worldwide, globalization of trade, and disparate strengths and weaknesses of the different analytical tools, we have an opportunity to develop complementary methods that build on each other's strengths. With a united front, we can streamline the research in areas like legality of globally traded timber and thorny taxonomic questions that intersect the ecological, economic, and social aspects of forests and trees. Genetics, chemistry, and machine learning are a new wave of resources that continue to advance in the future. This World Day, the multidisciplinary wood identification groups invites you to let cooperation take root.
Dear colleagues, dear friends, ladies and gentlemen, I will send you the best greetings from the Wood Anatomy in Hamburg. My name is Gerald Koch. I'm the curator of the Scientific Wood Collection at the Thünen Institute. Today, I will introduce the important rule of wood anatomy from tradition into the future. Although wood anatomy has been routinely described and successfully established for more than 100 years, fundamental developments will be forthcoming by the design of digital and automated identification system. Now I will give you some examples of this very important progress. One example is the development and application of the app CITES Wood ID, a modern tool for the identification and description of CITES protected timber. You can see the screen with very high valued images and the desktop which provides the information of CITES protected timber. Another example is the development and application of convolutional neural networks for automated computerized wood identification. We have used this technique for identification of species within the family of the Meliaceae, with very good results here shown in the confusion matrix, with a very high accuracy of more than 95% for the identification of true mahogany. A final example is the development of a vessel atlas for the identification of tropical timber in pulp and paper and fiberboards, where you need defined references for all international traded timber. All these examples shows and underlies the very important rule of wood anatomy and the very good progress in research for the future, especially with this contribution to control international trading according to timber regulation and CITES regulation. And in this, we have a very good future in wood anatomy. Many thanks for your attention.
Hello, my name is Teresa Pastori. Participants can see through presentations the most advances and research related to wood and identification. Various cutting-edge techniques have been demonstrated, despite the fact that these techniques are not readily available and required specific training. All of them possess a high potential for development and field implementation. Thank you very much.